up, we have Jessica Ezemba and James Afool.
Well, hello everyone. Thank you for the opportunity. My name is James, and I'm going to be talking together with Jessica about the project we worked on during the Byte Boost Cyber Training Workshop last year. And the title is Physics Aware Vision Transformer. Our thought process was that generally engineering simulations produce a lot of data. And so we wanted to see if it was going to be possible to come up with a foundation model or for us to train a foundation model for engineering simulations to make things better in a way. Please click on the next. Yeah. So we called ourselves Physics Alchemist, and I'll let Jessica introduce herself.
Yeah, thanks so much. Yeah, we're the physics alchemists with our nice logo on the top right. Um, a lot of my background, well, first I'm a third year PhD student at Carnegie Mellon, and a lot of my background is trying to merge engineering simulations and AI to make it more efficient and less error prone.
Nice. And I'm James. I'm getting my mechanical engineering PhD at Iowa State University, and my work primarily involves CFD simulations. So I run simulations of indoor environments and then outdoor environments, basically to make the building environment safer. Please move to the next slide. Talking about the project, right? So once again, our thought was that we put engineering simulations produce lots of data, and so we wanted to come up with a foundation model for this engineering data. What we did was that thankfully there was a data set that was curated by Polymathic AI. That's a team. The data set was the WELL, and so the WELL comprises of several benchmarks, well-known benchmarks or benchmark problems in 2D and 3D, including like the Rayleigh-Bernard convection, all of these very interesting problems. So we decided to work with the 2D data set to see if we can generate or get a general purpose AI for the automated analysis. I believe Jessica is going to talk about the thought process and how things went during the workshop. Please move to the next slide.
Yeah, so like James mentioned, the question we were trying to answer was we have these models that are very good at recognizing cats and dogs because they've been trained on a lot of cats and dogs, but we wanted to train from scratch our own model that's more focused towards engineering simulations. So a form of that model is something called a vision transformer, which is the VIT. And we wanted to ask how does this specialized VIT compare to the cats and dogs models, which is the CLIP and the DINO? Next slide. Yeah, so the objectives that we wanted to get through was find training from scratch our own physics-aware vision transformer based on some of the simulations that we saw on the previous slide, and then comparing that to engineering downstream tasks to see how well this new vision transformer compares with the general purpose transformers. Next slide. So these are some of the results that we got during the workshop. We were able to get it done during that week, so it is possible. What we compared against was Dino and Clip, and what we saw was that if you look at the accuracy in the first column, with the first row being the model that we trained, it's still on par with some of the existing large general purpose transformers, but where the model really excelled was with the remaining three columns was more physics-based tasks. So given a frame of this image, can you predict the next frame of this image, which is where the physics vision transformer excelled past the state-of-the-art general purpose vision transformers. And if you're looking on the right, you can kind of see what the embedding space looks at from a principal component analysis or PCA analysis. Dino and Clip looked pretty similar, but what we were able to train was very different. And we saw that it takes a fraction of the time to do so. So using the neocortex Cerebras, we were able to get a 70x speed up from CPU and a 12x speed up from H100s. So this was done and trained in less than a day. Next slide. So I wanted to end on some of the workshop experience. So we both of us have programming expertise, but not necessarily expertise with using some of these really nice test beds. So we mostly focused on neocortex and with the experience and the people that were trained in using neocortex, Sylvia, for example, was really able to help us fast track this project by being able to gain exposure to that. And we also were able to get access credits at the end of the program as well that we used later on. And then if you can click to the last part of this, we did face some challenges because of the size of the data to download. But I think overall was pretty successful. We were also able to present this externally at supercomputing late last year. So it was a real well experience for both of us.